welcome you all to session 2 of the chapter Motion in a Plane. In the last session, we have learned that physical quantities are of two types. One is scalar and another one is vector. Scalars are the physical quantities which have only magnitudes. Scalars can be expressed completely by expressing its magnitude itself, but vectors have both magnitude as well as direction. In order to express vectors, we need to tell it in terms of magnitude as well as direction, then only vectors are expressed completely. And also we have seen that scalars can be added or subtracted algebraically, but vectors cannot be added or subtracted algebraically. Then the question arises here is, how can these vectors can be added or subtracted? That will be the session of today. How mathematical operations work on vectors. Okay, let me begin with multiplication. The first section what we'll be studying in this part is multiplication of a vector by a real number. Right, so what is the meaning of real number? Instead of like that, shall I say it like this? Multiplication of a vector by a scalar. Right, so we know that. Okay, before I start with this, come on, tell me what is scalar into scalar. Right, if you multiply two scalars, what do you get? Scalar into scalar is always a scalar. Right, 2 into 2 is 4. Right, if you multiply two scalars, always you will be getting a scalar itself. Here you will be answering, what do you get if you multiply a vector with the scalar? Right, so this is the question of today. What do you get if you multiply a vector by a real number, or if you multiply a vector by a scalar? What do we get? Do we get a scalar or a vector? That will be the session of today. Right, okay, multiplication of a vector by a real number or multiplication of a vector by scalar. Okay, one thing we need to know here is, if you multiply a vector with a scalar, the answer is always a vector itself. Right, do you remember, if you multiply a vector with a scalar, you will be getting a vector. Okay, how do you get that? Let me check it out here. Right, so we need to understand here is, whenever you multiply a vector with a scalar, always you will be getting a vector. Okay, let me take two cases here. Okay, first one, case 1. Right, vector multiplied by a positive real number. Vector multiplied by a positive real number is a vector in the same direction. Okay, let me take case number 1. Vector multiplied by a positive real number is a vector in the same direction. Okay, let me check it out like this. Okay, let me take a vector now here. Right, so what is vector? Shall I take like this? A vector. We know vectors are represented by a letter and an arrow over it now here. Right, so this is a vector. If I multiply with a scalar, scalar means magnitude, magnitude means number. Right, a into 2. So what do you get now here? You will be getting 2a vector. Right, this is a vector into scalar. You will be getting a vector itself. For example, let me take like this. So this is a vector. Right, this is a vector. Right, if you multiply it by 2, we will be getting 2a vector. Means if you multiply by 2, we will be getting a vector whose magnitude is doubled. So what is the magnitude now here? It is 2a. So the magnitude is 2a vector. Right, so and this vector is in the same direction when a vector is multiplied by a positive real number. Right, if you multiply a vector with a positive real number, you will be getting a vector in the same direction. Right, so this is a. If you multiply it by 2, you will be getting 2a, and let me take like this. The length is doubled here. Okay, let me take. We know that the length of the line gives magnitudes and the arrow gives direction. Right, so the length of the line has been doubled here. This is a and this is 2a. Do you remember? Always a vector multiplied by a scalar, you will be getting a vector. If it is multiplied by a positive number, you will be getting the vector in the same direction. Okay, what do we get if you multiply by a negative real number? Okay, let me take that under case 2. Okay, same. Let me take like this. Vector multiplied by a negative real number real number. A vector multiplied by a negative real number is a vector in the opposite direction. Is a vector in the opposite direction. Right? Do you remember second? Vector multiplied by a negative real number is a vector in the opposite direction. Right? Okay, let me take a vector now here. So this is a vector. If we multiply it by -2 is negative real number. Right? It is a scalar quantity which is negative now here. Right? So what do we get now here? If you multiply by this, a into -2, you will be getting with -2a. Right? For example, if I am taking, this is a vector whose magnitude is like this much, and let me take it as a. If you multiply it by -2, you will be getting a vector like this, right? So you will be getting a vector and the direction is in opposite direction, right? Let me take like this. So magnitude is doubled, but the direction of a vector is in the opposite direction. So shall I say like this? This is -2a vector, right? If you multiply a vector with a negative real number, you will be getting a vector itself, but it is in the opposite direction, right? If it is a, it is -2a, right? So these are two cases. What happens if you multiply a vector by a scalar? The result is always a vector, right? It is in the same direction if you multiply it by a positive number. It will be in opposite direction if you multiply it by a negative number, right? So we have answered the question, what happens if you multiply a vector by a scalar, right? In the further session, we will be studying what happens if you multiply a vector and a vector, okay? That we will be learning, right? Now, let me move on to the next one. How to add the vectors, right? We know that vectors cannot be added algebraically. It can be added vectorially. And how to add that? That will be the next session here, right? Addition and subtraction of vectors. Let me take that and let me continue with this session here, right? Okay, the next subheading is about addition and subtraction of two vectors. Let me take like this. The next one is about addition and subtraction. Addition and subtraction of two vectors. Okay, how to add and subtract the two vectors. Okay, so in order to add the two vectors, so what we will be doing? How to add the two vectors vectorially? Okay, to add the vectors, we will be following some rules, right? There are two laws by which you can add the vectors. One is triangle law of vector addition. Triangle law of vector addition. The second one is parallelogram law of vector addition. Parallelogram law of vector addition. Okay, see here. In order to add the vectors, we have certain laws, right? Okay, the first law is triangle law of vector addition. The second law is parallelogram law of vector addition. You can use any one of these laws now here. Okay, so what are these laws? Let us check it out now. Okay, let me begin with the first one here, right? Triangle law of vector addition. What is that and how we will be adding? Let us check it out. Okay, the next subheading is about triangle law of vector addition. Let me take the side heading here, right? That is triangle law of vector addition. The first one, triangle law of vector addition. Okay, this is the next section, right? This is important section. Triangle law of vector addition. How to add the vectors. Okay, let me take, there are two vectors. Let me take, this is one vector. This is in the direction like this. This is a vector, right? Okay, let me take, this is b vector. Okay, the next question arises here is how to add these two vectors, right? Okay, I'll be using triangle law of vector addition. Okay, first of all, what we need to do here is we need to bring these two vectors together. How to bring? Okay, let me take equal vectors, right? What is equal vectors? It is a vector whose magnitude and directions are same. Okay, let me bring this a vector this side. Shall I bring here? Okay, I will be bringing this a vector. Okay, do remember, these two are not different vectors. Their magnitudes are same and directions are same. Shall I bring like this? Okay, this is a vector and this is a vector now, right? Okay, now I will be bringing this vector to that in that way, in that place now. Okay, shall I bring here? This is how. Which is this vector now here? B vector. Okay, these two are similar vectors, they are equal vectors, right? Magnitude is same and even the direction is same, right? Okay, I brought this vector this side and I also brought this vector this side. Now, shall I say like this? These two are two sides of a triangle. Let me take like this, right? Okay, now let me state what actually the law is. If two vectors are represented, see here, if two vectors are represented, right, in both magnitude and direction, okay, understood? If two vectors are represented both in magnitude and direction, right, if two vectors are represented by two, say, let me take, if two vectors are represented by two sides of a triangle, in order, let me take like this. If two vectors are represented by two sides of a triangle, that too in order, this word is important here, right? Okay, if two vectors are represented, how they are represented? They are represented both in magnitude and direction, right? Okay, let me write in the bracket. If two vectors are represented by two sides of a triangle, and how are they? They are in order. Okay, what is the meaning of in order? In order means this is the order which I am following. This is the order, right? It should be in the same order, right? So this vector must follow this vector. They are called as, they are in order, right? Okay, for example, if I am taking like this, if I am taking this vector and this vector, shall I say these two in order? Yes, they are in order because they are in the same direction. This vector follows this vector, right? Okay, in this way we can take. Okay, if two vectors are represented by two sides of a triangle, right, two sides of a triangle in order, then the resultant is represented, then the resultant is represented by, okay, say, then the resultant means the vector. If I am taking 2 plus 2 equal to 4, 4 is the resultant in that way now here, right? Resultant means the final result. What do we get now, right? A plus B is the resultant of addition of A and B. Okay, let me take like this. Okay, the resultant is represented by, okay, how do you represent the resultant? Okay, first of all, do you understand? Triangle has three sides. Already we have two sides. Which is the third side? Okay, this is the third side. Shall I say like this? Okay, this is the third side, right? Okay, see here. Then the resultant is represented by third side of the triangle. Third side of the triangle. See here, everybody. If two vectors are represented by two sides of a triangle in order, then the resultant is represented by third side of the triangle taken in reverse order. Do you understand this? Taken in reverse order. Okay, what is the meaning of reverse order? If I go with the same order, this is same order. Reverse order means reverse of this, right? Okay, this is in order. Reverse order is like this. Okay, where shall I put the arrow mark? Shall I put the arrow mark here or shall I put the arrow mark here? The law says that it is represented by third side of the triangle taken in reverse order. What is the meaning of reverse order? This is the in order, this is the reverse order. Means I shall take like this. And this gives which vector now here? Resultant vector. So what is that resultant vector? It is represented by R. Shall I say like this? Resultant vector R is equal to A vector plus B vector. Do you understand, right? So this is the resultant. Resultant means the addition of these two. So these are the resultant vectors, right? Resultant vector R is equal to A plus B. Okay, do you understand? Once again, what is triangle law of vector addition? If two vectors are represented by two sides of a triangle, how? The two sides of a triangle taken in order, right? If they are in order, then the resultant is given by which side? Third side taken in reverse order. Okay, shall I say like this? In the reverse order. So what is this R here? R is equal to A plus B. So this law is called as triangle law of vector addition. Usually ask for 2 marks, state and explain triangle law of vector addition, and you need to explain like this. right? Okay, so this is how, this is r vector is equal to a plus b vector. Okay, shall I say take another one example here, right? Okay, instead of taking like this, shall I take like this is a vector and b vector is in this direction. Okay, then how to add these two vectors? Shall I use triangle law? Yes, I can use. Shall I bring a this side? Okay, bring this vector to this side. Shall I say like this? This is vector. Which vector now here? A vector. Shall I bring b that side now here, right? Because the vectors must be taken in order, right? Okay, I will be taking this side. So what shall I? This is which vector now here? B vector, right? These two are equal vectors. These two are equal vectors, right? Okay, what does the law says? If two vectors are represented by two sides of a triangle taken in order, is it in order? Yes, it is in which order? This is the order, right? This vector is following this vector. A plus b means A must follow B now here, right? Okay, this vector is this. Okay, where is resultant of A plus B? Resultant of A plus B is represented by, according to law, it is represented by third side. Okay, where is third side? Okay, this is third side. And where is the direction of that? Third side of a triangle taken in reverse order. Shall I take arrow mark this side or this side? I need to take this side, right? Because its arrow mark should be taken in the reverse order. Okay, what is this vector? This vector is A plus B. Do you understand, right? If you want to add the two vectors, you need to make it as two sides of a triangle. Then the third side gives the resultant of A and B, and third side must be taken in reverse order, right? This is all about triangle law of vector addition. You can add two vectors either by triangle law or by parallelogram law of vector addition. Now let us move on to the second law, that is parallelogram law of vector addition. Okay, let me remove this. Okay, let me take parallelogram law, second law, that is parallelogram law. Parallelogram law of vector addition, right? Okay, let me take like this. Now, parallelogram law of vector addition. You know, parallelogram is a quadrilateral which has four sides, right? Parallelogram is like this. It has four sides. This is called as parallelogram, right? Okay, where opposite sides are equal and parallel, right? Okay, that is the name, parallelogram, right? Okay, the second law, parallelogram law of vector addition. Okay, let me add the same two vectors taking parallelogram law. Let me take, this is which vector over here? A vector, and I need to add this vector, which is this vector over here, B vector. Now, this time I will be adding these two vectors by using parallelogram law. Okay, how to make that? Let me check it out now, right? Okay, if two vectors are represented in magnitude direction at a point, this is the difference between parallelogram law and vector law now here, right? Okay, see, if two vectors are represented at a point, if you want to use parallelogram law, we need to bring those two vectors at a point, right? Okay, if two vectors are represented at a point by two adjacent sides of a parallelogram law, okay, let me take like this, and this law is called as parallelogram law. Okay, if two vectors are represented at a point by two adjacent sides, because since they are having four sides now here, there are adjacent sides, and adjacent sides means if I am taking like this, these two are adjacent sides, right? Okay, and these two are parallel sides, right? Do you understand? These are adjacent sides and these are parallel sides. Okay, now if two vectors are represented, how they are represented? At a point, do remember, at a point, right, by two adjacent sides of a parallelogram. Okay, let me take adjacent side. Okay, what shall I do? Shall I bring A to that side? Okay, I will be bringing A this side. Shall I take like this? This is A vector. Do remember, this is not different and this is not different. Both are same. They are equal vectors. Okay, now I need to bring B vector this side. Did you understand? Okay, this is which vector over here? B vector, right? So I am bringing these two vectors at a point, that is, right? If I want to use triangle law, I brought this vector to this side now, right? But now I am using parallelogram law, so I need to bring these two vectors at a point, right? So this is A vector, this is B vector, and this is I am bringing at a point now here. Now, if two vectors are represented at a point by two adjacent sides of a parallelogram, then the resultant vector, then the resultant is represented. Then the resultant is represented by, okay, resultant means A plus B, right? Then the resultant is represented by the diagonal of a parallelogram. Diagonal of the parallelogram. Okay, let me take now here. Then the resultant is represented by the diagonal of the parallelogram. Okay, where is the parallelogram? Shall I complete parallelogram first? Okay, let me complete it. How to complete it? You know, parallelogram is a quadrilateral where opposite sides are equal and parallel. Okay, I will be completing this. Shall I complete? Okay, this is how I need to complete. Right, this is parallelogram. Right, let me take like this. This is the parallelogram. Right, so in this parallelogram there are two diagonals. One is this diagonal and another one is this diagonal. Okay, remember the resultant is represented by the diagonal of the parallelogram drawn from the same point. Do you understand this? Drawn from the same point. Which point? This point. At a point I have taken now. Let me take that same point itself. The diagonal of the parallelogram drawn from the same point. Okay, where is the point? This is the point. I need to draw a diagonal from the same point. Means from this I need to draw the diagonal, and this is which vector now here? R vector. Right. Then the resultant is given by R vector is equal to A plus B. R vector is equal to A plus B, right? So do remember this is the resultant vector. R is equal to A plus B. Okay, resultant is given by diagonal of the parallelogram, that to which diagonal? Taken from the same point, because there is another one diagonal, it does not represent resultant, right? The resultant is represented by diagonal of the parallelogram taken from the same point, right? So this is R, and let me take R is equal to, what shall I take now here? A plus B. Did you understand? Right. So this law is called as parallelogram law of vector addition. Do you remember parallelogram law of vector addition? The resultant is represented by diagonal. In a triangle law of vector addition, the resultant is represented by third side taken in reverse order in triangle law. Right. In parallelogram law, it is resultant is represented by diagonal of the parallelogram taken from the same points. Okay. Okay. Let me give another one example here. Let me take another one example and tell you about the parallelogram. Okay, there is one, let me take like this. There is a vector, this is A vector, and let me take, this is B vector. Shall I take like this? Now I need to get what is the answer for A plus B. Where is the vector A plus B? Right. Okay, so do remember, if I want to add these two vectors, right? Okay, shall I take like this? Shall I bring A this side? Okay, this is A vector. This is A vector. Shall I bring B vector this side now here, right? I will be bringing the same here, right? Shall I bring like this? This is which vector now here? P vector, right? These two are same vectors. These two are same vectors. Okay, now the question arises is, where is A plus B? Okay, what to do that? I have got it. Okay, now I need to not to bring this side, because the rule says that the two vectors are represented at a point. Means where shall I bring now here? This side at a point. So let me bring this B this side. So which is this vector now here? B vector. Shall I bring this side? Because two vectors are represented at a point. That is the thing here, right? At a point. Now what shall I do? Shall I complete parallelogram? Okay, I will be completing the parallelogram. Right? Let me take, if opposite sides are equal and parallel, let me take like this. Now I completed parallelogram. Okay, let me write it neatly. Right? So this is how I have completed parallelogram. Okay, if I am completing the parallelogram, right? If I am completing the parallelogram like this, then where is A plus B? A plus B is given by diagonal of the parallelogram taken from the same point. Where is the same point? This is the same point, and this is, what is this now here? This is A plus B, right? Okay, this is a resultant of A plus B, which is taken from the same points. This is parallelogram law, right? You can add any two vectors either by taking triangle law or by taking parallelogram law, right? When you take triangle law, take the two vectors in order. Whenever you take parallelogram law, take the two vectors from the same points. In triangle law, third side gives the resultant. In parallelogram law, diagonal gives the resultant. Okay, we need to remember this in order to add the two vectors. Okay, one thing is clear here. Whenever you add two vectors, do remember here, whenever you add two vectors, the result is always a vector itself. Okay, do you understand? Whenever you add two vectors, vector plus vector, whenever you add a two vector, you will be getting a vector itself, right? Okay, by understanding this, let me take now here, right? Now we understood how to add two vectors. The next question arises here is how to subtract two vectors, right? Okay, the next is subtraction of two vectors. Let me take that in the note point. I will not be taking in detail. Okay, that's we'll be learning by considering the triangle and vector parallelogram law itself now. Okay, how to subtract two vectors, right? Okay, for example, let me take like this. If this is a vector, shall I take like this? This is a vector and this is b vector, right? This is a vector and this is b vector. Now I want what is a minus b, right? The next question is subtraction of vectors. We have understood addition of vectors. Now I am moving on to the subtraction of vectors, right? I will not be introducing any different law. I will be using the same thing here, right? Okay, shall I take like this? Okay, now shall I bring a this side? The same thing, right? I will be bringing a to this side now, right? Now I will be bringing a. Shall I take like this? I will be taking a negative vector. You know what is meant by negative vector? A vector whose magnitude is same but direction is opposite. That kind of vector is called as negative vector. Shall I use like this? I will be using negative vector concept here. Okay, a I have already bought. I want minus b. Okay, how to get minus b? If b is in this direction, minus b is in opposite direction, right? Okay, if I am taking a minus b, I want now, right? Okay, for example, if I am taking this is a and this is b, right? Now, shall I bring b? Okay, let me take like this. This is which vector now here? B vector. But I don't want b. I want what now here? Minus b. How to get that? Let me take this side. This side. What is this now here? Minus b vector. I don't want. Just for understanding sake, I took that. Okay. Now see here. This is a vector. What did I take? I took a minus b vector. Right? Okay. Now this is a vector and this is minus b. Which law shall I use here? Since they are in order, I will be using triangle law, right? If I am using triangle law, which side gives resultant of these two vectors? Third side. And how we need to take third side? We need to take third side in reverse order. Okay, which is order? This is the order. I need to take third side. Here I need to take third side, but in reverse order. Okay, this is what now here? This is resultant, right? Third side of a triangle taken in reverse order. Okay, what do you get this? According to triangle law of vector addition, we know that this r vector is equal to a vector plus, what do you get now here? Minus b vector. Shall I take like this? This r vector is a plus of minus b. What is this a plus of minus b? That is a plus into minus is minus b vector. Did I get a minus b? Yes, I got a minus b. Okay, a minus b. Okay, what is that? Let me take like that. Subtraction of a vector is the addition of negative vector. Is the addition of a negative vector. Simple. Subtraction of a vector is the addition of a negative vector, right? If you add the negative vector, you will be getting the subtraction itself, right? So there is no other rule or law to calculate subtraction of vector. Okay, let me go with that. That's why I have written in terms of node now, right? Subtraction of a vector is the addition of a negative vector. If you want to make a minus b, okay, take a, take the reverse of b and conclude. You will be getting a minus b itself, right? So a minus b, you will be getting like this. So do remember what is subtraction of a vector? Subtraction of a vector is the addition of a negative vector. Do understand this? This is how we will be subtracting two vectors. Now let us move on to the next concept, that is resolution of a vector. Okay, what is resolution of a vector? Resolution of a vector is splitting of a vector into two or more components. Two or more components is called resolution of a vector. Resolution of a vector. Okay, first of all, we understood what is the resolution of a vector. Resolution of a vector is splitting of a vector into two or more components, right? Because this concept is very much useful for the further concepts to study now here, right? Resolution of a vector. What is the resolution of a vector? Splitting of a vector into two or more components, right? You can split a vector according to your convenience now, right? So resolution of a vector is a splitting of two vectors, right? So into two or more components is called resolution of a vector now here, right? Okay, let me take like this. If a vector is resolved, see here, if a vector is splitted, if I'm taking, if a vector is resolved along two mutually perpendicular directions. See, let me take like this. If a vector is resolved along two mutually perpendicular directions, then the components are called rectangular components. Rectangular components of a vector. Let me take like this. Understand this. Okay. What is resolution of a vector? First of all, we understood resolution of a vector is a splitting of a vector, right, into two or more components is called resolution of a vector. If you split the vector along two mutually perpendicular directions, what is the meaning of two mutually perpendicular directions? X and Y, mutually perpendicular directions, right? If I'm taking X and if I'm taking Y, if you split a vector along X axis and Y axis, and those are called as mutually perpendicular directions. If you split a vector along the two mutually perpendicular directions, then the components are called rectangular components, because I will be using this word again and again. Rectangular components. What are rectangular components? These are the components of a vector which are resolved in two mutually perpendicular directions. So those are called as rectangular components of a vector. Okay, let us understand this diagrammatically, then we will come to know what actually the resolution of a vector is. Okay, let me take like this now, right? Let me take, there are two vectors. Let me take, this is a vector. Let me take like this is a vector. Which is this vector? Shall I take this vector is a vector? Okay, shall I resolve it? Shall I split it? Yes, I will be splitting it. How will I split it? I will be splitting it in along two mutually perpendicular directions, means along X axis and Y axis. Okay, let me take like this. This is which axis? X axis. Shall I take like this? This is which axis now? Perpendicular, and this is Y axis. Shall I take like this? Okay, I will be splitting the vectors, right? Okay, now I will be splitting in this way. This is let me take, this is like this. Let me split this along this direction. Shall I take like this? This is along this direction. Now this is the angle. Let me take, this angle is theta, right? Okay, let me split this along X axis. Shall I take AX? Right, AX is a vector along X axis. Let me take like this. Similar, this is, what is this now here? AY, and this is, right? Okay, now a vector I split into AX and AY. Do you understand here? Whatever the result A gives, these two vectors together gives, right? Like this, AX plus AY, right? The result of the two vectors will be equal to the result of a single vector, right? Because I have split this two vector into two components. Do you understand? Splitting of a vector into two or more components. Here I took an example of two components, right? Vector A is split into two components. Which are those two components? AX and AY, right? AX and AY. However, this AX and AY, they are mutually perpendicular to each other. Shall I call them as rectangle component? Yes, I can call it, because I split A along X axis and Y axis, and they are mutually perpendicular to each other. That is why I will be calling AX and AY as rectangular components, right? Okay, do you understand this? Now, if vector is in any direction, we can split along x-axis and y-axis. What is that process called? A resolution of a vector, right? This is a vector, I split into ax and ay, and this is the angle. Let me take that angle as theta. Now, the question arises here, how much is ax and ay? Let me calculate, right? Okay. Now, if I see this diagram, let me name it O, M, N. Shall I take like this? O, M, N. Okay. From a right angle triangle, what does that mean here? O, M, N. Okay. What is the right angle triangle? This is the right angle triangle, right? Exactly. Here it is 90 degree. Here it is 90 degree. This is a right angle triangle. Okay. What is that right angle triangle here? O, M, N is a right angled triangle, right? This is a right angle triangle. If the triangle is right angle triangle, I can use trigonometry here, right? You have learned about trigonometry, sin theta, cos theta and tan theta, okay? Now, what I will be doing is, I need to calculate what is this ax and ay. I need to calculate what is ax and ay. Come on, tell me. In this triangle, where is hypotenuse? OM. OM is hypotenuse, okay. What is ON? Which side is ON? Is it adjacent side or opposite side? If I am taking theta here, this is adjacent side. And what is MN? MN is opposite side. Shall I take like this? Okay. See here, once again, in triangle OMN. OMN is a right angled triangle, which is hypotenuse. OM is hypotenuse, which is adjacent side. ON is adjacent side, which is opposite side. MN is opposite side. Now I'll be using trigonometric functions here. Okay, come on, tell me, what is cos theta equal to? Right, what is cos theta? You know, what is cos theta? Cos theta is the ratio of adjacent side divided by hypotenuse, right? You know, what is the formula for this? It is adjacent side divided by, what we say here? Hypotenuse, right? You have learned this. Cos theta is adjacent side divided by hypotenuse. Let me take like this. Come on, tell me, what is adjacent side here? ON. For theta, this is hypotenuse, this will be adjacent side. What is adjacent side? ON divided by, what is hypotenuse here? OM. OM is the hypotenuse. Shall I take like this? ON divided by OM. Right, come on, tell me. Now, what is ON here? ON, what is this thing here? AX. Right, shall I say like this? ON is nothing but AX vector, but this is a distance. I want only magnitude. Shall I take like this? Modulus. What does modulus gives? Only magnitude, right? Okay. Divided by, what is OM here? It is OM. OM. Which vector is it? It is A vector. But I want only magnitude because OM is the distance, OM is the length. I want only magnitude, right? So always the modulus represents magnitude. We have learned in the last session, right? So AX divided by A. Shall I take like this? This can be written as, okay, let me write here. This can be written as AX divided by A, because I can remove this arrow mark so that I will be getting only magnitude. Okay, what do you get? AX divided by A. Come on, tell me. Now what is AX equal to? AX equal to, shall I bring A this side? This is what now here? Cos theta. If I bring A this side, what do you get? A cos theta. So what is AX equal to? AX equal to A cos theta. Did you understand? Right? This is how I calculate the component of A. That is AX. AX equal to A cos theta. Okay. I calculate AX. Now I'll be moving on to the AY. Okay. Now in the same triangle, which is a triangle OMN, I took cos theta. Now I'll be taking which theta now here? Sin theta. Okay. What is the formula for sin theta? Opposite side divided by hypotenuse. Right? Shall I say like this? Opposite side divided by hypotenuse. Right? Come on, tell me, what is opposite side for theta? Which is opposite side? MN. MN divided by hypotenuse. What is hypotenuse? OM. Shall I take like this? Come on, tell me, what is MN equal to? What is MN equal to? Shall I say like this? This MN is equal to this, right? What is this? That is nothing but AY. Shall I say like this? Right? MN, this distance equal to this distance. And what is this? This is AY. So what shall I take now here? AY vector, but I want only the length. So I'll be taking magnitudes. Okay. What is OM? OM is A vector. Shall I take like this? This is A vector. Okay. Whenever I take modulus, I need to remove that AY divided by A. Shall I take this? Come on, tell me, this is which theta equal to? Sin theta. What is AY equal to? AY equal to A sin theta. A will come this side. We will be getting with A sin theta. Okay, what are this AX and AY? AX and AY are rectangular components of vector A, right? So this is A and these are components and these are rectangular components. What did I get? AX equal to A cos theta. What did I get? AY equal to A sin theta, right? So these are the rectangular components of vector A. Once again, what is the resolution of vector? Splitting of a vector into two or more components. If we split it along two mutually perpendicular directions, then those components are called as rectangular components. And we have seen how actually the rectangular component of a vector is calculated. By using trigonometry, I have calculated Ax equal to A cos theta, Ay equal to A sin theta. Now let us take the derivation of expression for magnitude and direction of resultant of two vectors. So we came to know that if A and B are two vectors, then R is the resultant. Then what is the formula for R? Let us derive it now. Okay, now derivation of expression for magnitude as well as direction of a resultant of two vectors, because we know that if you take vector plus vector is always a vector and that resultant vector has magnitude and direction. Let us find what is the formula for magnitude and direction of the resultant vector. Okay, let us begin with the derivation. Let me take two vectors here. See, understand? Let me take two vectors. This is A vector and I will be taking another vector in this way, and this is let me take it as a B vector, right? Okay, let me take like this. This is A vector and this is B vector, and I need to add these two, right? Since these two are from a point, then which law shall I use here? Here I will be using parallelogram law, right? Since these two are vectors are from a point, then I need to use the parallelogram law. Okay, in order to use the parallelogram, first I need to draw the parallelogram, right? Okay, this is A and this is B. Let me complete the parallelogram. Okay, this line must be equal to this line, right? And this must be equal to this, right? I have completed the parallelogram. Let me take this is O. Okay, according to the parallelogram law of vector addition, which side gives resultant? Diagonal from the same point. Okay, which is the same point? O is the same point. Shall I draw the diagonal? Yes, I will be drawing the diagonal. Okay, if I am drawing the diagonal and this gives what we say here, resultant from parallelogram law of vector addition. Okay, I have considered two vectors A and B. Okay, now let me take this angle. But what is that angle now here? Theta, right? Okay, let me write. A and B are two vectors making angle. What is that angle now here? Theta. Shall I take like this? Okay, I have considered two vectors A and B making angle theta. Okay, means angle between A and B is theta. Let us consider like this. Now, what is the resultant? Let R vector be resultant of A and B. Okay, shall I say like this? Let R be resultant of A and B, right? This is the resultant vector of A and B. Which vector now here? R vector. Okay, now I need to derive what is the expression, right? As I need to derive the expression, let me continue like this. Let me make some construction here, right? Whenever you have derived with the theorems, right? I used to do construction. Here also, let me do some construction. Okay, let me take like this. This is the construction which I am making it now here. Let me take like this. Let me take a perpendicular. Here also, let me take perpendicular, right? Let me call it as O. Let me take P, Q. Yes, let me take it as N. Okay, now I have made this construction. Why did I make this construction? Because the triangle which I got is an obtuse angle triangle, right? But in order to use trigonometry, I want a right angle triangle. So I need a right angle triangle, right? If it is not constructed, right? Okay, there is no right angle triangle here. That's why I constructed this to get right angle triangle. Come on, tell me, what is this angle? What is this angle? Right? If this angle is theta, this angle must also be theta itself. Why? Because they are corresponding angles, right? If I'm taking these two are parallel lines, then if I draw a tangent like this, if I draw a line like this, these two angles will be equal because they are corresponding angles, right? So this is theta, this is Mn, right? Okay, I have made this to get a right angle triangle. Okay, let me calculate it now here first of all. Now let me begin with the calculations. Now this is a triangle. Let me take, in order to prove this I need some space, so let me remove this and let me make some space to calculate it. Okay, let me take like this, from triangle. Okay, a right angle triangle. Which is a right angle triangle? Shall I take this is a right angle triangle, right? PSN is a right angle triangle. PSN. Okay, from a triangle, which is a right angle triangle, PSN. PSN is a right angled triangle, right? As PSN is a right angle triangle, we know that. Shall I take like this? Come on, tell me, what is sine theta equal to? Right? So I will be taking both the angles now here. First, let me take sine theta and I will be taking cos theta. Now, what is sine theta? This is theta. What is sine theta? Sine theta is the ratio of opposite side divided by hypotenuse. What is opposite side of theta? Sn. This is the opposite side. Shall I take Sn divided by hypotenuse? What is hypotenuse? Ps. Shall I take like this? Ps is the hypotenuse. Right? Okay. Now, what do I get? What is Sn and what is Ps we got now? Come on, tell me. What is Sn? We don't know. Okay, shall I write like this? Sn, I don't know what is Sn. Let me keep like this. But I know what is Ps, man. What is Ps? This Ps is equal to what? OQ. Right? See here once again. Ps equal to OQ because it is a parallelogram. Opposite sides are equal and parallel. Ps equal to OQ. What is OQ? B. Shall I take like this? OQ is B. Okay. What do I get? That implies Sn equal to B. Shall I take this side? B sine theta. Okay. I have calculated what is Sn. Construction which I have done, I am calculating what are those sides now here, right? How much is that side? Sn is equal to, what is that now here? B sine theta. Okay, let me make the similar manner there. What is cos theta? This is theta. What is cos? Adjacent side divided by hypotenuse. What is adjacent side of theta, man? Pn. Okay, Pn divided by hypotenuse. What is hypotenuse? Ps. Let me take. Ps is the hypotenuse. Pn, I don't know. That is what I calculated now here, right? Let me take like this. Come on, tell me what is Ps, man? This Ps will be equal to this. And what is that now here? B, right? Okay, let me take. This is B. That implies what is the Pn equal to? B, I will be bringing this side from here, right? B cos theta. Okay, do you understand? The construction which I made Sn equal to B cos theta, Pn equal to B, Sn equal to B sin theta, Pn equal to B cos theta. The construction which I have done, I calculated it first now here. Now, let us calculate what actually this R is, right? Okay. Now, let me take from triangle. Let me take this. I want this R, right? So, I will be taking a bigger triangle here. This because I want R. Shall I take like this? In triangle OSN, this I will be taking. Why I am taking this? Because it is a right angle triangle, right? Okay. From triangle, what is that? OSN. What is that here? OSN. This is the right angle triangle which I am taking now here, right? I want hypotenuse, that is R, right? Whenever I need hypotenuse, if there is a right angle triangle, which law shall I use now here? Pythagoras theorem, right? What is Pythagoras theorem? The square of the hypotenuse is equal to sum of the squares of the other two sides. Okay. Now, what is the hypotenuse of this triangle here? OSN. This is a right angled triangle. What is hypotenuse? OS is the hypotenuse. Shall I take like this? OS square equal to sum of the squares of the other two sides, right? What is the other two sides? ON and SN. Shall I take ON, sum of the squares of the other two sides, right? Okay. What is that now here? What is the other side now here? ON square plus SN square. Shall I take like this? The square of the hypotenuse equal to sum of the squares of the other two sides. OSN. OS square equal to ON square plus SN square. ON square plus SN square. Now come on, tell me, what is OS, man? OS is R, right? What is ON? ON. I don't know what is ON, but I know what is OP, right? Okay. What is SN? SN. Okay, I got it. What is SN here? B sin theta. Okay. Shall I take like this? See here, one thing you need to understand. What is ON? See here, ON. I don't know ON, but ON can be written as OP plus PN, right? Okay. Shall I write ON as OP plus PN? OP plus PN whole square plus SN square, right? So ON can be written as OP plus PN. Now I know all the terms now here. Let me substitute and let me calculate it. Right. Come on, tell me. What is OP, man? What is OP? OP. What is this? A. Shall I take A plus. What is PN? PN. What is this? I calculated already PN. What is that now here? B cos theta. B cos theta is PN. Right. So let me take like this. Square plus. What is SN, man? SN is B sin theta. Shall I take like this? B sin theta square. Right? See here. OP plus PN. OP is A. PN we calculated B cos theta. SN is B sin theta. Now you know how to calculate this. This is a plus B whole square. What is A plus B whole square? A square plus B square plus 2AB. Shall I use that? Okay. Now by using these two, PN value and SN value, I calculate. Let me continue with the derivation again. Okay, let me remove this. Now come on, tell me, what is A plus B whole square? A plus B whole square. A square plus B square. What is the square of this? B cos theta. Square is B square cos square theta. Do you remember? B cos theta square. It means B square cos square theta. Both are the same, right? So that is why, what is B cos theta square? B square cos square theta, right? Plus, what is the formula for A plus B whole square? A square plus B square plus 2AB. This is AB. Okay, 2AB. What is this B now here? B cos theta. Shall I say like this? So this is the formula. A plus B whole square. What is A plus B whole square? A square plus B square plus 2AB, right? Plus 2AB plus. Come on, tell me, what is this? B sin theta whole square? B square sin square theta. Shall I take like this? Now, in that expression, B square is common in both two terms now here. Shall I remove that side? A square. Let me take B square. Okay, here also there is B square, here also there is B square. What is present here? Cos square theta. What is present here? Sin square theta. Shall I write like this, right? In that two terms, B square is common. Let me take common. What is remaining here? Cos square theta. What is remaining there? Sin square theta. What is left out now here? 2AB cos theta. But in trigonometry you have learnt what is cos square theta plus sin square theta, right? Sin square theta plus cos square theta equal to 1. That you have learned it now, right? Okay, let me substitute by 1. What do I get now here? A square plus B square. Because it is 1, let me take it. What is remaining now here? 2AB. What shall I get now here? Cos theta. Come on, tell me, what is OS square? OS. What is OS? R. OS square. Instead of writing OS square, shall I take now here? R square, right? The same. What I want now here? R I want. What is R equal to? Square root. Let me take like the square root of what? A square plus B square plus 2AB cos theta. And this is the derivation for magnitudes. What is the formula for resultant vector? R equal to square root of A square plus B square plus 2AB cos theta. So this is the formula for magnitude of resultant of two vectors. Right? Okay. So R is equal to, what is the formula for here? R equal to square root of A square plus B square plus 2AB cos theta. Do remember, this is about the magnitudes. How much is R? Right? So do remember, I already told you resultant cannot be added algebraically. Resultant R is equal to not A plus B. It cannot be A plus B. If it is A plus B, it is algebraic addition. Here is not A plus B. Then what it is? R is equal to square root of A square plus B square plus 2AB cos theta. Do remember this formula. This is very important. whenever we calculate about vectors, whenever you need to add the two vectors, this formula must be there, right? You need to remember this formula, that is r is equal to square root of a square plus b square plus 2ab cos theta. Okay, now this is about magnitude, but the derivation is not only about magnitude, you need to go with the direction. Okay, shall I go with the direction here, right? So let me move with the direction here, right? If I want to calculate the direction, let me take like this. This is magnitude. Let me move with the direction. So one thing what you need to remember here is, whenever we go with the direction of a vector, always the direction is taken in terms of angles, right? Do remember, direction north, south, east, west, we will be speaking day-to-day life. But in physics, whenever we speak about the direction of a vector, we take how much angle from another vector, right? We will be taking some reference and we will be taking some angle. Okay, come on, tell me here. If I am taking this r as a resultant vector, right? Shall I take, let alpha be the angle. Okay, what does that mean here? Let alpha be the angle made by r with a. Theta is different, it is angle between a and b. Alpha is different. Since I am taking direction, I am taking alpha. What is alpha now here? Alpha is angle made by r with a. Let me write. Let alpha be angle made by r with a. Right? Let alpha be the angle made by r with a. Now I need to calculate what is the alpha. That is r now here, right? What is this now here, right? Let me take what is the direction here, right? In order to take direction, right? So there are two vectors a and b. I need to write in terms of a and b itself, right? So a and b, I don't want a direction here. I want only what is the direction of this resultant. So I need not to include the direction, right? Let me take in triangle OSN. Let me take the same thing now here. What is that now here? From triangle OSN. Okay, what is the triangle here? OSN, right angle triangle I am taking, right? I want the direction of A, so I need not to include hypotenuse. If I need not to include the hypotenuse, then I need to take a trigonometric function which does not include the hypotenuse, right? Means which trigonometric angle shall I take? Shall I take tan now here? Yes. Sine? Okay, there is a hypotenuse. Cos? There is a hypotenuse. I will not be using sine and cos now here. Now, what shall I take now here? Tan alpha. Okay, I will be taking tan. Why I am taking tan? Because I need not to include this r now, because I am calculating the direction of r itself, right? Okay, what is tan theta equal to? What is the formula for tan theta? Opposite side divided by adjacent side. Come on, tell me what is opposite side of r? So, sorry, opposite side of alpha. Opposite side is Sn. Shall I take like this? Sn divided by, what is adjacent side of alpha now here? Adjacent side is On. Okay, Sn divided by On. Right, you know what is Sn here, right? So we have already calculated earlier what is Sn here, right? But what is On? On, shall I write like this? On can be written as OP plus Pn, right? Okay, once again, On can be written as OP plus Pn. Okay, shall I say like this? Sn divided by, On can be written as OP plus Pn, right? OP plus Pn. Right. Now, come on, tell me what is Sn? Earlier we have already derived what is Sn. Sn is B sin theta. We already calculated here. What is Sn here, right? That is B sin theta, right? Sn is B sin theta now here, right? Okay. Then what is OP? OP is, what is OP? OP is what now here? A. Plus, what is Pn, man? Pn we calculated. What is Pn? Pn is B cos theta. Earlier itself we have calculated. I have written here two brackets and completed there, right? So, what is Sn here? Sn is B sin theta. What is Pn? Pn is B cos theta, right? So, what is the tan alpha equal to? Tan alpha equal to B sin theta divided by A plus B cos theta. Right, so this is the formula for direction. Okay, what is the formula for direction of resultant of two vectors? Direction is represented by angle. Which angle? Tan angle, that is tan alpha. What is the formula for tan alpha? B sin theta divided by A plus B cos theta. Right, so do remember, if A is making an angle, right, alpha. So the direction is represented by this formula. There is a tan alpha equal to b sin theta divided by a plus b cos theta. So this is the end of the derivation, right? Derivation will be asked in the examination. Derive the expressions for, right, expressions for magnitude as well as the direction of the resultant of two vectors. So we need to derive like this mathematically, taking this diagram, writing this right systematically, derive what is the magnitude. And let me take direction later. Second part I will be taking direction. Direction is taken in terms of alpha, so tan alpha, and this is the expression what we get. So this is the direction of resultant of two vectors, right? So in the next session we will be learning how to multiply a vector with the vector itself. What will be the result of that? That we will be discussing in the next session. Thank you.